have Luis Espino talk about rice pest management updates. So Luis, if you want to share your slides.
Okay, good morning, everyone, and thanks for attending today. I'm going to talk about here, if I can advance my slide, basically a couple of updates on one on armyworms, a little bit of work that we've done this year, looking at insecticides and then the effect of defoliation on plants. And then I'll spend most of the talk on rice diseases. I'll try to give a quick update or a quick background information on the main diseases that we see on rice fields. And then I have some information on some fungicide work that I've done this year. Okay, so I'll start with the armyworms. So we didn't have a lot of problems this year. In general, it seemed like the armyworm pressure was low, maybe moderate. I know there was quite a bit of Intrepid use, and maybe that's why we're not seeing the problems, because we're controlling the issue. But we continue doing our moth trapping. So you may know that we have these set of traps. We have 15 traps in different sites across the valley, and we check them weekly, and we count the number of moths that we get. And that graph you see there is the number of moths per day. And what you can see is we have two distinct peaks, and for 3 years now we've seen the same pattern, where we get one peak, about late June, early July, and then the next one is in mid-August. And those peaks coincide with when we see larvae in the field feeding and kind of the peak of the problems in the field. So we've done a lot of monitoring and trying to count larvae and try to correlate that to the number of moths we're getting. And we just don't have a good relationship between how many moths you get on a trap versus how many worms there are in the field. But what we do see is, like I said, the peak of the moth catches gives us the peak larval activity in the field. So if you know when you're reaching or approaching the peak, that's when you need to make sure you're monitoring, which, as you see, is about the same time every year. But it's a good reminder of when is it that you have to be on top of this and making sure you're getting in the field and looking for the larvae. So we've always talked about two species of armyworms that we can find on rice, the true armyworm and then the western yellow striped armyworm. And over the years, I've heard growers and PCAs kind of refer to both of them as being in rice. So since the outbreak of 2015, we've been monitoring closely rice fields. And last year and the year before that, this year, 2020 and 2019 was the first year that I was finding some western yellow striped armyworms. But the westerns, I wasn't finding them eating on the rice. They've been feeding on rice weeds. So that picture there, you can see the western yellow stripe is feeding on red berry. And there was a real big patch of red berry in this field, and the westerns were just hitting that and defoliating the red berry, but they were not feeding on the rice. And I haven't seen any defoliation on rice caused by the western yellow striped armyworm. And so it seems that the data seems to indicate, or the observations, that really the armyworm that's a problem for us is a true armyworm. So if you happen to see the western yellow striped armyworm, is much darker. It's about the same size as the true armyworm as it grows, but it has this velvety look, and feeling. Like if you touch it, is really soft. It's really pretty, and it doesn't seem to feed on rice. So that's good. So if you find that, that's something that you might not have to worry about treating. Now this year, I got a notice from the Ag Commissioner, one of the Ag Commissioner biologists in Glenn County, and they were seeing some western yellow-striped armyworm migrating from an alfalfa field. And they were getting complaints from some of the neighbors. They were getting into the houses. So it was a big migration. And I didn't get there that day, but I got there like a day or two later. And I was able to see the westerns, on the alfalfa field. There were quite a few defoliating, but then they were moving out of the field. And as they moved, they were defoliating, eating the weeds. I don't know if you can see that the armyworms there, they're basically on stalks because they ate all the foliage of the weeds around the field. And then they were moving out of the field. They went over a canal. I guess they swam, and then they went over the pavement into the road, and they were moving to neighboring fields, probably into the weeds because there was nothing really. It was orchards, so there was no rice around this area. But this was very interesting to see how the behavior of the armyworms. That's why we call them armyworms, because they move sort of like an army. But again, not on rice, so that's good to know. We had an armyworm insecticide trial, and this was on a rice field with some heavy defoliation, but not enough to warrant a treatment. As you know, we've been getting Intrepid every year as a Section 18, and full registration is on the works. It might be 2022 when we get it. I'm not sure yet, but and we're hoping to get it again in 2021. And so we had Intrepid in our trial. We had Prevathon, which is chlorantraniliprole. That's it's a product that's not registered on rice right now. We've tried it in the past, and it's worked good, and we're hoping that it becomes available sometime in the future. And then we tried Dipel, which is a BT, so it's an organic insecticide, a bacterial insecticide. We didn't include Lambda or Warrior because we've tested it several times in the past, and we don't get good control with Warrior. And in fact, we didn't include it in this trial, but we had another trial right next to it where we were testing an additive. So we were testing the Lambda with an additive to see if we could increase the efficacy of the Lambda, and it didn't work. We saw no differences with the untreated. But anyway, so on this trial though, we counted the number of worms we could find during 2 minutes for every plot. And so we did that at 0. So before we put out the treatments, 4, 6, and 11 days after the treatments. And here's the number to look at, is the % reduction from the pre-treatment. And Intrepid and Prevathon give us really good control, over 90%. That's what we've seen in the past. Dipel didn't get to 50%, and that's what we also seen before. When we put this treatment, it's about the time when you start seeing the defoliation. So the worms are already past the initial instars. They're bigger. And so Dipel is just not as effective as it is when you treat really small worms. But then something very interesting we did this year is we went back, we left the plots in place, and then we came back at heading. So about 60 days after we put our original treatments. We didn't do any more treatments. We just came back, and then we assessed how many panicles were injured by armyworm during heading. And it was really clear that there was a residual effect of the Intrepid and the Prevathon, where we saw very few injured panicles, where we didn't have the control early on with the Dipel and the untreated. There were much higher number of injured panicles. So there is a residual effect. We're kind of thinking about how is this happening. We know, for instance, with Intrepid, we have some information from the manufacturer that the residual that we usually see is 20 days, which is a very good residual. But I don't think what we're seeing is that the products still on the leaves as the armyworms are feeding on the panicles. It might be that we're catching the very early instars that emerge from eggs that get laid late, and those are the ones that are going to produce panicle injury. So we're not sure how we're getting this residual effect, but we're getting it. This is a benefit, and so we're going to probably look at this again next year to confirm and see if we get the same effect. So we've done some artificial defoliation trials, and why we do artificial, it's because finding fields that are defoliated and untreated, it's really difficult. And we do this at the Rice Experiment Station in Biggs, and over there we just don't get armyworms. And so we just we put our plots, and then at the armyworm timing, we just go in and defoliate it manually. Defoliate the plants manually with pruning shears. And so we defoliate to three levels. So we get a plant height, and then we defoliate 25% of that, 50%, or 100%. And we do it through a period of 3 days to kind of mimic, the armyworm doesn't feed on everything in one day. It takes a little bit of time. And then this year we had 3 varieties, M105, 206, and 401. And we wanted to see if there was maybe some differences on how the varieties respond to armyworm damage. And maybe M105 can recover faster, or maybe M401 it's affected more than other varieties. So we looked at that, and in conclusion, really, we didn't see a difference on how the varieties respond. They all respond about the same. And what we see is that the plant height is affected. The plants that get defoliated 100% and 50% are shorter, and they are never really able to catch up. 25%, they catch up, they recover. And the other aspect that gets affected is panicle size. So we get shorter panicles when we get defoliation of 50 and 100% of the foliage. We didn't see an effect on how heading progressed or on number of panicles per square foot. Those seem to be unaffected. So the plants are able to put the same number of panicles per square foot, and about at the same time as the controls, but the panicles are smaller, the plants are smaller. And then we saw an effect on yield. And when we have 25% defoliation, we don't see any yield effect. But when we got to 50% and 100% defoliation, we get a yield effect. And so very small at 50%, 4% yield loss, and 26% yield loss when we defoliate 100%. And when I say 100%, this is to the water level. So we cut everything to the water level, just like the armyworm would do. They eat everything, and they leave a little bit of the tiller up above the water. So this is kind of indicating that our thresholds that we currently use, 25% is our threshold. It's a good threshold. At that point, we shouldn't see any yield effects. It's when we go above 25%, 50% that we start seeing yield reductions. Okay, so now I'm gonna move into the diseases. And so I'm gonna start with stem rot. This is a disease that's pretty common. You'll find it in every rice field. In recent years, I've been getting more and more calls about stem rot. When it's bad, you'll see something like this. A lot of the tillers have these black lesions at the water level. Later in the season, you see the white sporulation of the fungus. And what this causes is lodging. The lodging looks a little different than sometimes you see the fields that lodge and they're really flat. In this case, when you get stem rot lodging, the plants tend to break down here at the water level, and so the lodging looks really not even, not uniform. You see a little bumps in the field. Then you get a lot of blanking. You're not getting the movement of nutrients from the different parts of the plant into the kernels. So you're not filling all the kernels. So you get quite a bit of blanking. And then later in the season, if you split up one of the tillers that are affected and look inside, you'll see this black kind of like sand. And what those are the resting structures of the pathogen. They're called sclerotia. And they play a very important role in the disease, because as these sclerotia accumulate, you get more disease every year. And nutrient management also plays a role in this disease. So you'll get more stem rot if you have excess nitrogen, and also if you get a low levels of potassium. And as a reference here, on a soil test, you're looking at 120 ppms as your threshold. So if you're below that on potassium, you might not see a deficiency in the field, but it might be providing favorable conditions for stem rot development. You can get yield reduction, and we've seen that in some of our trials. And so management is really a lot about residue management. So you want to make sure that you're decomposing the straw. The sclerotia survive in the straw. And so if the straw is removed or burnt, then you're getting rid of the fungus. If the field is winter flooded, that helps as well, because you're degrading that straw, and that is gonna also kill the fungus. On a year like this, where we have a lot of straw out there, and there's a lot of fields are dry, it's warm, those sclerotia can germinate and produce more sclerotia. So these are favorable conditions for the pathogen. So residue management, it's key. Nitrogen and potassium fertility, use nitrogen to maximize yields. Don't go over that. So you have to know your field. You have to know what is the nitrogen level that's going to get you your top yield, and assess the need for any top dressing. And like I said, potassium, take a soil samples, check your potassium levels. And then there's fungicides that can be used. And we've been doing trials for a few years now, and we see Quadris, active ingredient azoxystrobin, gives us control, reduces the disease severity. So this is a trial from this year, and we had Quadris at a couple of times. We sprayed Quadris at the boot stage, and then at the early heading stage. And these are really close in time. The mid boot stage, it's when we have a panicle of about 4 inches inside the boot. And then the early heading is about 10 days later. So they're really close in time, but we wanted to have the boot timing, because we're having some growers that have problems with smut. And so for smut, the timing of application is at the boot stage. And so if we target that stage, can we get, if we target smut, can we save an application by including our stem rot and aggregate sheet spot timing sprays at that time? And looks like we get good control, or similar control as we get when we do our treatments at the early heading stage. We've done several years testing the propanil timing, about 35 to 45 days after seeding, because that was a timing that a lot of growers were taking advantage of that propanil application to add a fungicide in there. And we haven't seen good results putting a fungicide on stem rot or aggregate sheet spot. So we added we tested another fungicide that's registered for rice, Stratego. It's a similar active ingredient as Quadris. It's within the same group, it's trifloxystrobin, and we did not see as good results. So there's a little bit of a reduction in disease severity, but not as good as with Quadris. And then we tested an organic product, and organic growers really don't have anything that they can use. So we've been looking for the past few years, but this product did not work. Aggregate sheath spot is the other disease that is very similar to stem rot. It affects the tillers. So early in the season, you'll start seeing these lesions. They're kind of gray green, and they have a very distinct border to them. And what happens is these lesions start moving up the plant, and as they move up, they affect the leaf sheath, and then the leaf blade starts first it turns yellow, and then eventually it'll die. And so it takes foliage. It kills leaves, and that can result in yield reduction. And if it gets very severe, it'll go up to the panicle. I haven't seen that in the past 5 years or so that I've been working on rice diseases, but it can get severe. And then it produces, similar structures that we call sclerotia. They're a little different. They're not black, they're brown. And again, it's similar to stem rot. Those sclerotia go back into the soil. And then as you accumulate sclerotia, the disease starts getting worse and worse. So this disease is very sensitive to potassium. So if you have low potassium levels, you're probably going to see aggregate sheath spot. And you might not need a fungicide. All you need to do is bring up the potassium levels back to normal, back to optimum, and you will see the disease go away. We've seen yield reductions, and so management, again, residue management, so that you don't accumulate those sclerotia. Making sure you have adequate potassium in the soil, and then fungicides. And we've been testing fungicides for this disease also for quite several years now. And again, we tested 2 timings, the boot stage and the heading stage, trying to see if we could save on application costs, thinking of kernel smut. And Quadris gives us good disease reduction at both timings. Excalia, which is a new fungicide, is not registered yet, but it's going to be available hopefully in the next year or 2. It's a different fungicide, it's a different mode of action, different active ingredient, and it's excellent on this disease. Unfortunately, it's the only disease that has a really good effect on, but it's really excellent. And it's just used at 2 ounces per acre. And then Quilt Excel. Quilt Excel is a mix of Quadris and Tilt, so azoxystrobin and propiconazole, and it has the same amount of azoxystrobin as Quadris, and so it gives us very similar control as Quadris. And then we saw a yield effect here, averaging out the yield increase on these treatments where we saw disease reduction. We were gaining 650 pounds to the acre, so a 7% yield increase. So this was a very good trial. Kernel smut, it's another disease that we've been seeing lately. It was first seen in California in mid-1980s, and really it didn't give problems, or it didn't cause any problems for a few years until maybe the mid-2010s, when I started to hear concerns from PCAs asking me, what is this kernel smut? We see it more and more. It didn't seem to be causing any issues at that time, but 2018 was really bad. 2017 was bad too. And what it does is replaces the kernel with this mass of spores, and it can be partial or it can be the whole kernel. We get spores that are in the seed, or it can be in the soil, and we don't understand the cycle of the disease very well. But the pathogen is favored by excess nitrogen and high humidity. So whenever we have, 2018 was a year where we had the fires early a little earlier than this year, and that might have been a factor, providing more dew, more humidity during the late part of the season. There's an effect on yield and grain quality. We had some trials this year where we saw a strong effect on yield. And so management is making sure you're using the amount of nitrogen that you need to maximize your yield and don't go over that. There's some effect of which variety you have, and then fungicides. And I have some slides on that. So here's the SMUT on different varieties. So this is the number of SMUTted kernels in 25 grams. It's a sample we take at harvest. And about what we see in general, and what we've seen over the years, is that the medium grains are less susceptible than the long grains. And then the short grains are even less susceptible. You can see that with Kalahikari 202, we didn't have much SMUT. S202 had quite a bit in this trial, but in other trials, we've seen some short grains have very little SMUT. And then out of the medium grains, 209 always seems to be the one that has the most SMUT. A long grain here, L207, had the highest level of SMUT, but L208, another long grain, doesn't seem to be as susceptible. Talking to the breeders, they tell me that they both have very similar genetics. So the reason why they're different, it's not totally clear. Then we had a trial looking at the effect of nitrogen, and I'm just showing here the untreated plots. And so we had this is with a A201, an aromatic long grain, and we had a nitrogen level of 150 pounds, and then a nitrogen level of 170 pounds. And just adding those extra 20 pounds increased the level of SMUT almost twofold. So we got almost double the SMUT just by adding that extra nitrogen, and we didn't get any benefit on yield. So very important to go with your nitrogen rate that maximizes yield, and don't go over that. On the fungicides here, Tilt and Quilt Excel gave us disease reduction. So Tilt is propiconazole, Quilt Excel has propiconazole, and that seems to be what's doing the work here. We tried other fungicides, some organic fungicides. One of them had a little bit of an effect, but not much really. And there was a question about SMUT and in the seed, and is bleach helping us? We do this bleach soak of the seed. Does that have any effect on the SMUT spores? So we did a trial in collaboration with Texas A&M, and the short is no, it doesn't seem to help. So we don't get any reduction in spore germination if we treat our seed with bleach. So actually in this experiment, we saw more SMUT germination when we treat the seed with bleach. So it doesn't seem that the bleach does anything for us. I just have two more slides. And I wanted to talk about blast real quick. Blast was bad this year, especially on the north part of the valley. We can get leaf blast, panicle blast, which is the phase of the disease that causes the most problems. I'm not going to go over much detail. I think all of us are pretty familiar with blast by now. But I did wanted to mention that when it comes to varieties, this year, M205 and M209 were just terrible with blast, where, PCAs were doing 2 applications and still the blast was coming, was still affecting the field. So many times I brought up M210. It's a resistant variety, but I got a lot of questions about, how it behaves. And so I wanted to show this table here. M210 is really an M206 with blast resistance. And so this is 4 years of data from our statewide variety trials. And really yields are the same as M206. Days to 50% heading, plant height, lodging, they're basically the same. So, you know, if you're in one of these areas up in Glenn County, Colusa, Butte County, where you see blast regularly, this variety would be a good option. I mean, you wouldn't have to worry about blast. This variety is resistant. And that's my last slide. I think now, Sarah or Renee, we're gonna launch the questions. And sometimes it takes a little bit of time. And so I have 3 questions, so make sure you scroll on the little screen. So the first question is, true armyworm is highly susceptible to pyrethroid insecticides. Is that true or false? I think we talked about that. The second question is, the best fungicide application timing for management of stem rot and aggregate sheath spot is propanil thyme, mid-boot, early heading, or both mid-boot or early heading. And then the third question is, which macronutrient can increase the severity of kernel smut? Nitrogen, phosphorus, potassium, or calcium? And so I'll let you guys think about this for a few minutes. We got 40% of you have answered. Remember, you don't have to get it right. You just have to answer to kind of prove that you were awake and still sitting in your chair. But this will be good practice for the actual test that you have to take to get your credits for DPR. And we got now 70% of you answered. We're getting there. Remember to scroll down so you see question number 3. We'll give it one more minute. Let everybody answer the questions. Well, we do that. I was going to mention, I wasn't sure if I was going to have time. You know, when I talked about potassium and aggregate sheath spot, I had a field this year where we had set up a trial, and it had just terrible aggregate sheath spot. And so we took leaf samples to see what was the potassium level, and we were getting, 0.2, 0.3%, and the optimum is 1.5%. So we were way below the optimum potassium level, and that's why we were seeing such severe disease in that field. So we're going to talk to the grower and make sure they address that, and I'm sure addressing that potassium is going to go a long ways in fixing the disease issue. So we're at 86%. We got 1 minute. So I'm just going to end the poll now so we can look at the results. Okay, so true armyworm is highly susceptible to pyrethroid insecticides. So that is false. We just don't get good levels of control with pyrethroids. Even when we treat early to try to catch the small worms, we just don't get good control. We tried piperonyl butoxide, which synergizes the pyrethroid, and it just didn't work. The best fungicide application timing for management of stem rot and aggregate sheath spot, it seems to be the mid-boot or early heading. So at those times when we use a fungicide, we seem to get the best response. Propanil thyme, I think last year, I counted out of 18 trials, we saw good results with propanil thyme in 1 trial. So in general, propanil thyme is just not the right time to put fungicides. And then what macronutrients can increase the severity of kernel smut? And yes, it's nitrogen. Nitrogen, just a little bit of extra nitrogen as shown by the trial this year, can really make a big difference into how much smut you get. Okay, so I'm gonna stop sharing, and I'm almost out of time, but if there are questions, I'll be happy to address.
Yeah, if you have any questions, please type them in the chat for Luis and he can answer them during the break. Thanks.
Okay.